version 4, subnet masking, and we want to go over and start the actual work, the project. So there is under week 4, which was actually last week, an online lab 1 IP addressing worksheet. Does everyone see that?
Yes, sir. I saw it. I don't know if anyone's going to answer. I'm going to answer.
Yeah, okay, so let's open that up. And once we have that open, let's start going through that and just kind of go over what it's asking. And then I want to do, start us out here with some ideas on what to do for this. Okay. So what we have is this scenario, planning an IPv4 network. This scenario, A.Datum Corporation is an international organization with its North American regional office located in Toronto, Canada. They're planning to open 3 new branch offices in different cities in Central and North America. The branch offices will be in Houston, Texas, Mexico City, Mexico, and Portland, Oregon. The following table describes the planned computer distribution in the branch offices. So Houston, Mexico City, and Portland, it breaks it down into desktop computers. Just share my screen here as I talk.
Hey, Gary, can you mute your phone?
Hello.
Gary,
I'm sorry.
can you mute your phone?
Okay. So here we have Houston, Mexico City, and Portland. You are the network engineer. You need to determine how you're going to subnet these 3 different offices. Houston has 300 desktop computers, 100 laptop computers, and it says connecting to both the wireless and wired networks. And then 50 tablet computers only to the wireless network. And then the same thing is for New Mexico City and Portland, except different numbers: 100 desktops, 50 laptops, 20 tablets, and then Portland 100 desktop, 75 laptop, and then 150 tablets. Okay. All right. So it says A.Datum will be using Microsoft Office 365 for all email and file access for the Central and North American branch offices, with some shared folders located in the Toronto regional office on servers running the Windows Server operating system. Because all offices have fast and highly available network connections to the Toronto office, A.Datum is not planning to deploy any servers in the branch offices at this point. So we're simplifying it, where all we have to focus on is just the PCs, laptops, and tablets. There's not going to be, okay, we're not getting too specific. We're not talking about voice over IP phones or printers or other things, which I'm sure we would have, but just very simplistic. 3 things to be concerned about. And so the team is assigned the following subnet range. This subnet range, okay, is a 172.16.18.0/18. So this is to be used for the North American region. So it's a big chunk of IP addresses, but which currently contains the Toronto office and the 3 new branch offices. So this is one big group of IP addresses that can be used to be divvied out amongst Toronto as well as Mexico City, Houston, and Portland. So the central IT guys gave us these ranges, okay? So for network devices, they're on the 18 network /24. So the 18 net, that's when you do a /24, again, what does that mean? What's the /24 mean?
Anyone out there?
Okay, so Teddy, what does a /24 mean? Teddy Barber. Have to take yourself off mute.
I actually have a question.
Yeah.
I know you're recording, but I noticed the recordings haven't actually been posted on Moodle.
I've got a link to a YouTube channel where they're at,
Oh, okay.
and it's on Moodle.
I see now. Thanks.
Okay, Teddy, are you there?
Yeah, I'm here.
Okay. What does a /24 mean? I mean, you can say I don't know, but what do you think it means? What's a /24? You have to take yourself off mute. Hey, you want to turn on your video too?
I'm not sure. Is it part of an address or something, or a location?
So a /24 is the binary bits in a subnet mask. Okay, so what would a subnet mask look like then with a /24? Do you remember what a subnet mask is, Teddy?
It's like a network number.
Yeah, it actually determines how many IP addresses and subnets there are, is what the subnet mask is. Give me give me like a generic subnet mask. What would that look like? What would be a number for a subnet mask?
Can I say it?
Yeah, sure.
Isn't it 255?
Okay, say the whole subnet mask.
Oh, I think it's 255 again, right? And then 255 again, and then 0.
Okay.
Correct.
All right.
Okay, I was right. Oh my God.
Yeah. So that is a /24. This is a CIDR notation. That's what it's called. That's the acronym. Okay. And what this means is if you break this down into 8 binary bits, this is 1, 2, 3, 4, 5, 6, 7, 8. And if you count those up, the 1 and the 2 and the 4, this is binary, right? 8, 16, 32, 64, 128. If you add those all together, if you plus those all together, that equals 255, okay? So that's why each of these numbers is 255 because it's 8 binary bits. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the final number is a 0. So it's just it's either ones or zeros. So it has to be all, it's all zeros. It's 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So this is a binary representation of the number above it. And this is, of course, decimal. These two are the same numbers, okay? If 255.255.255.0 is decimal, the same equivalent number below it is in binary is 8 ones point, dot 8 ones dot 8 ones dot 8 zeros. So these three groupings or four groupings make up your subnet mask in decimal or binary. All right. So if this is the first 8 bits here, all right, 8 plus 8 more bits plus 8 more bits in binary, and that's where the ones stop, right there, right at that right after that third octet. It's an octet because there's 8 ones, binary ones. That's why they call it an octet. So these three groups, or octets, 8 plus 8 plus 8 equals 24, or 24 bits. Okay, Teddy, does that ring a bell?
Yeah, it does. I just had one question. So the 255, it can be any number, or just it has to be 255 and then so on?
Yeah, that's a really good question. So with a subnet mask, these numbers are going to be, it depends on the class of address. So if you have a class A, okay, let's erase this for a minute, okay. All right, so if you have a class A address, it starts out, this first group has to be between 1 and 127. But 127 is a special number, which it's only for loopback, so it's really 126. That's class A. Okay, and then class B is 128 through 191, and C is 192 through 223. Okay, and then D is multicast, and that's 224. Okay, that's multicast. That's your Netflix, Apple Music, things like that. Okay, well, when you have the number, in this case, their number is 172.16, okay, 18 or 19 or 20, whatever. This is 172 net. So when you say 172, that falls between right here in the B, the class B, okay? So 128 to 191. And so with the class B, the default mask, all right, the default mask for each of these is, okay, for the mask for these is, if it's a class A, right here, class A, it's 255.0.0.0. So it's really an 8-bit mask. That's the default. And with the class B, it's 255.255.0.0. So that's a 16-bit mask, right? 8 plus 8. And then C is 255, 255, and 255.0. So 3 bits, 3 octets, or 24 bits. These are the default masks, okay? Now, to your question, Teddy, when you have a class B like this 172 here that we're dealing with our homework assignment here, or our little lab, okay, 172, these first two are locked in. And with an A, the first one's locked in, and with a class C, those three 255s are locked in. But after that, that number can be different. Those zeros can be replaced with different numbers to determine how many IP addresses are for each subnet. Okay, so that's
So then,
where these bits come in. Go ahead.
the 255, what class would that, I mean, does it tell us that which class it's in?
Which one?
255, like those numbers are there. 255, the 8-bit, 16-bit, 24-bit.
Okay, so yeah, so these numbers here is the 5 here. So
I have a tandem question as well, sir. Kind of
okay,
in
yeah,
that same. So would it be wrong in assuming, because for the online lab, it indicates it's a 24-bit, and if I'm understanding this correctly, a 24-bit is only ever going to be 255, 255, 255, which is automatically going to be paired to the class C type of subnet class.
yeah. So yeah, I think these defaults are just what that means, just default. But that doesn't mean they can't be changed. So what happens? Let's take this class B here, this 172 net. So it starts off these first two here are just, that's it. That's all you can do with these. They're just 255, 255. All right, those first two. But after that, you can change, this can be a 0 and a 0 and a 0 like this, or these could still stay ones, and these could start becoming ones right here. You can start doing that, okay? So wherever those ones stop, that's what happens with a mask. Now, in the case of a class C, the first 3 octets, those first groupings of 8s, cannot be changed. But then, even though you start out with 255, 255, 255.0, you can start putting ones in here. And if you put ones in here, let's say we put 4 ones and 4 zeros, then what happens is, instead of that being 255, 255, 255.0, then you say, okay, the subnet, this is going to go up here. And those 4s, 2 to the 4 is going to be the subnets. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, this is going to be 16 subnets. And this is going to be 2 to the 4 minus 2 is going to be 14 IP addresses, or nodes, or hosts, IP hosts, host IPs, for each of these subnets. 16 times, really 16, but 2 are unusable, but 16 times 16 is 256. So you preserve the 256 in a class C, but this number here, what does that change to? Well, this is the 128-bit, this is the 64-bit, this is the 32-bit, and this is the 16-bit. So all added up is 240. You add those up. 128 plus 64, that's 192. Plus another 32 is 224. Plus another 16 is 240. So you put 240 into that 4th area. And what that says is, I've got 16 subnets and 14 IP addresses per subnet. So it's less than 256. What it's done is taken those 256 and subdivided into 16 subnets. So you can always, you take what's the default there, and then you can modify that as need be. Does that make sense?
For me, a bit more than before I asked my question. So yes.
Okay. Okay. So, all right. Now, in the case of this 172 net, now, oh, what was your question again, Teddy? You had a question as well.
I asked, what determines the number to be in a class? Like because we were talking about 1 to 126 is class A, 128 to 191 is class C, and so we ended up at class D with 240, I think. So I just wanted to know if there's something that goes beyond that.
Goes beyond class C?
D. Class,
Oh, D.
Class D.
Yeah. D, there's some experimental ranges past D, but they're not really used. So
Oh, okay.
really, these ranges here, which is that beginning octet, that first group, decimally, if it's 1 to 126 class A, 128 to 191 B, 192 223 C, and then multicast is 224, and that's pretty much it.
Okay, thank you.
Yeah. Okay, so this whole thing right here is a workshop in this subnet masking, changing those bits to get what we want for these subnets that we're proposing for Houston, Mexico City, and Portland. And so if we know this, okay, then we know that every time we change this subnet mask, and we can now change into this here, we can change this, okay? We can change those because by default, this is, it starts out 172, so that's a class B. So just the first 16 bits are the network. They call that the network portion of the subnet mask. Even though it's a subnet mask, remember there's a network portion. Then there's the actual subnet that you can modify, right? You can't modify the network portion because that's locked in, but you can modify the subnet. And that subnet can go not just in the third, but extends in this case, right? It extends all the way to here. And then right here is the nodes. That determines how many IP addresses per subnet. Okay, so that's what we're doing with this worksheet here. We are trying to determine, well, how many IP addresses do we need? Okay, so they've given us some ranges. Okay, the 19 net here, it's a class B, 172.16.19. So I'm just going to talk about, these networks in the third octet. Like this is the 18 net, this is the 19 net, and this is the 20 to 2052 net or something, this is a range, okay? So it says network devices in that 18 net, servers, printers, okay, in the 19 net, desktop computers anywhere between 20 net and the 52 net, and then wireless devices between the 53 net and the 60. It's like a range here. You can put them in. Okay, so they've given us these things, and they say, here's your ranges of IP addresses. And then they're saying, well, how are you going to set it up? Okay. And so for this scenario then, okay, you need to plan the IP address segment assignment for each Central and North American branch office. Your IP addressing scheme must meet the following requirements. Wired and wireless clients must be assigned IP addresses from different IP address ranges. They want to keep these separate for whatever reason. Each branch office location must have dedicated IP address ranges so you can't overlap. Keep subnets in branch office locations as simple as possible. Ensure that branch office subnets have IP addresses for all potential wired and wireless clients that might request one. Okay. So here's your questions, 1 through 13. This is the end of it right here. You just need to answer these 13 questions. Okay, let's start with number 1 here. How will you determine the number of IP addresses required for each location? So how are we going to determine that?
Wouldn't that just be the like actual devices? I mean, if you have 300 desktop computers, for example, in Houston, and 100 laptop computers that need a wired and a wireless, and
Yeah, let's go back up to this table and let's take a look at this. Okay, so let's take Houston. All right, so I'm just going to start picking on people that I haven't heard from. Let's say Matt. Matt Mokai. Okay, okay, show me your face and take yourself off mute. And how many IP addresses do you think we're going to need for Houston? Might have two things running.
My ears, that hurt my ears seriously now.
It's okay. So you had another device on that had a mic. You've muted that one. Okay. So Matt.
Yeah.
Okay. Turn your video.
Okay.
And so we can all see you here. Okay. Tell us for Houston. They said they wanted separate networks for wired, meaning those that plug into an actual wire, and wireless, those to connect to the Wi-Fi access point. So how many IP addresses are we going to need for wired and wireless in Houston?
So can you repeat the question one more time?
Yeah. So for Houston here, here's your numbers right here. Okay. How many IP addresses are we going to need to set up for Houston for wired and wireless devices?
Um, 450.
Okay, so so for wired, how many? And for wireless, how many? It's two separate numbers. I mean, if you added them up, that's 450. That's
100.
what?
400 wired and 150 wireless.
Okay, so Matt, why?
I think.
Why would he say 400 for wired and 150 plus for wireless? Why would he say that?
Well, because 50 tablet computers are connecting onto the wireless network, and then 100 are connected to both wired and wireless.
Yeah. So they could be, people could come with their laptops and just open them up and be wireless, right? So what's worst case scenario? All 100 laptops come into the office, open up, do not plug into a cable, and they're all on the wireless. And so the maximum is 150, right?
Yeah.
But they could all, but what's the worst case scenario for wired? All 100 laptops come into the office and they plug into a wire. They plug into the cable right there on the desk. And so now they're part of the wired network. So they can go either or. So you're right.
Yeah.
400 is going to be for wired, because that's the worst, I guess, not the worst case scenario, but you know what I mean. That's the maximum case scenario. And then those all laptops could be wireless, and so that plus the tablets, that's 150. So that's the IP addresses you need: 400 for wired and 150 for wireless in Houston. And that's all we're dealing with. We're not going to deal with printers. We're not going to deal with other things that we would need IP addresses for, right? Which normally we would, but we're just simplifying it. Just talking about desktops, laptops, and tablets. Okay. So if we break that down then, okay, let's take Houston. All right, Matt, here we go. We're gonna take Houston and we're gonna say 400 for wired and 150 for wireless. Okay, this is Houston. Okay, I don't like red. I'm gonna go to blue here. Okay, now let's go back to this. And we're saying, okay, desktop computers, which is, think of that as wired. That's in this range, the 20 net to the 52 net. And then 53 net to the 60 net is for wireless devices. So okay, so then what would a valid IP address be for the wired computers slash laptops? What would be a subnet that you could use that with a mask that would give you 400 IP addresses?
Sorry, what was the question?
So for wired computers in Houston, well, Houston, Portland, and Mexico City, all three of them are using this range right here. Some subnet within this range, 172.16.20.0 through 172.16.52. Okay, and so even though this is a Class B network because it starts with 172, a Class B network can be broken down into multiple Class Cs, right? It's like you take this Class B and then you can break it down into multiple smaller segments, like we talked about with the whiteboard. So you could have a 20 net, you could have a 21 net, 22, 23, 24, all the way up to 52. So Matt, what would you choose for Houston as the subnet? Any guesses? You can just take a guess. Doesn't matter if it's wrong or not.
Uh,
Are there multiple correct answers?
Yes, there are.
Can I say it?
Yeah, go ahead.
It's anything less than 24. So like 23, 22. Because we're doing 400, right? So 23 is 512, 22 is 1024, 21 is 2048, like that, right?
Yeah, so if you've got Houston here, and here you've got, you've got your connection, here's your router here, here's Toronto's router, and you have to use a range between 172, 16, 20 through 52, somewhere in there, right? So here's Houston, here's Mexico City, and then Portland, okay? You've got to then spell out which ranges you're going to use. Portland. So you're right. You have to, because if you just did, let's say you just took the 20 net. Okay, Matt, if you do 172.16.20, okay, .0 with a slash 24-bit mask, how many IP addresses do you have, Matt?
So that'll be 255.
4096.
So you've got, if you just have a /24, that gives you a 24-bit mask. And the 24-bit mask, what that really means, that 24 really means 255, 255, 255, 0. And what that means is standard class C. And the only thing left is these zeros are eight zeros actually. And if you add up those 8 zeros binary, 4, 5, 6, 7, 8, what do those add up to? If you add up these numbers that I'm putting in right here. 128, 64, 32, 16, 8 plus 4 plus 2 plus 1. If you add up all those together, what's that equal?
I'm doing the math, sorry. 48.
Plus 4 plus 2 plus 1. So 128 plus 64. That's what's 192 right there.
Oh wait, wait.
Yeah, you got these are the numbers. I put them to the side here so you can see them better.
Oh, okay.
So 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. Because each of these is, that's the 1 column, that's the 2 column, that's the 4 column, you know what I mean? That's the 8.
255.
255, that's right. 255. So these, you have 255 addresses and plus 0. 0 counts as an address, so technically 256, but yeah. So here you have 255, right? You have 255 addresses if you did that. 172.16.20.0, that's subnet, the 20 net right there. Plus that mask, 255, 255.0 gives you 255 addresses. But you need how many?
400.
You need 400. So you see the 20 net's not enough.
Mm-hmm.
You're not going to make it. You're going to have too few addresses. So you've got to go higher than that. Okay. All right. Good job. So who knows then what, thank you, Matt. Who knows what needs to be done to get this up to 400? And wait, the first question is, can you ever have exactly 400 addresses?
I don't know, but that's not fair because I was going to
No.
ask that.
You can never have 400 addresses. There's only so many addresses you can have, because when we go back up to this, what we did up here, okay, if I change these nodes to a bigger grouping, okay, this was broken down into like a subnet, they call it. It's below 256. 256 is kind of like that limiter. All right. So here we are, and we're going to make this bigger. We're going to make this all zeros again. And okay, 0, 0, 0, 0. So here's our 8 zeros. And now we're going to take out this little line here that we had, okay? And all right, so my computer's trying to catch up. So this was 256, because it's really 255 plus 0. 0 counts as a number in binary. So just add one more to 255, you got 256 IP addresses right here, okay, with this kind of mask, 255, 255, 255.0. But now, okay, what's weird is you can go to the left here, all right, and you can start changing these to zeros. Now, if this was the 128 column, 28-bit column, right? And it's always doubling in binary, right? 1, 2, 4, 8, 16. What's after 128?
256.
256. So when you added 128 plus all these other numbers, you got 256 plus another 256. What do you have now?
512.
You have 512 addresses. Your mask has changed now to, you took away 1 bit. So that was the 1 bit in the 3rd octet, but now you're adding it to the 4th. It's a little weird here. But when you do that, that was the 1 bit. So 255 minus 1 is 254 here. And now you've got, it's like you've got 7 bits or 7 ones in the third octet and 9 bits in the 4th one, which gives you 512 IP addresses. So you can only double these numbers: 256, 512, 512 plus 512, 1024, 2046, 4096. See, so you're doubling. You can never have 400, but you can have 512, which is pretty close to what you need. You need 400 in Houston. You need 400 IP addresses.
So I have a question, sir. In that
Yeah.
regard, it just goes in intervals
That's right.
of
It's just
doubling, and there's no middle ground for specificity for like a number like 400.
Yeah, you're just out of luck. That's just how IP addressing works. And so you're going to have waste. You're going to have IP addresses that go unused. Like in the wired, you only need 400, but you're just going to have 512. That's all you can do. So 112 are going to go unused. Well, some number thereof, because not always 400 is going to be used. But yeah, and that's just how it works. Yeah. So there's waste there.
Okay, gotcha.
Okay. So now we need to do a different mask. We need to change this mask from a 255.0 to 254.0. What is the CIDR notation for that now? So Ian, what's the CIDR notation for this now? For a 254.0 subnet mask. What's that CIDR notation? What's that equal to? The CIDR notation right here. This number here. So Ian, you got to take yourself off mute. You there, Ian? Ian, you there? Maybe he took a bathroom break. Okay, who can answer this for me?
Well, quite simply, Mark, since we're removing one of the leading ones and extending our administrative reach, it'll be 24 down to 23.
That's right, it's just a 23-bit. That's it. That now becomes a 23-bit mask because you just took the 1 off of there, 1 bit, which was the 1 bit, and now it's a 23. And if you were to go to a 22, you take the first 2 off of there, and the first 2 is the 1 column and the 2's column. So 2 plus 1 is 3. 255 minus 3 is 252. So now it's 252. So there are certain numbers only that you can change this to. But as you start doing this, that gives you 1,024 addresses. This gave you 512 addresses. This /24 was giving you 256 addresses. So for 400, we really only need to go up to this one, a /23. Now here's the question that throws everybody off. Okay, you do a /23, your subnet mask now is 254.0. Okay, here we go. You got 512 addresses. Where did the 512 addresses come from? That is the sticky point. People, that's a hard one for people to figure out. We started with the 20 net, and the 20 net, then we knew that this 20 net is equal to 256. So now the only way to get another 256, okay, is to combine the 20 net with the 21 net, okay? The 20 net has 256, this, slash 24. So 2 slash 24s are 256 addresses. Two 24s together is 512. So now I'm using the 20 net and the 21 net. So those two networks, the 20 and 21 net, that's giving me this 512. Okay, that's giving me the 512 here. Okay, with this mask. The mask says 254.0. That means the router says, oh, you need 512 addresses, so I'm going to give you the 20 and the 21 net. Okay. All right. So,
Sir, I have a question. So for example, in the lab, it gives you that range. Now that you're using that to, I guess, subnet and make more addresses, that limits the range which you can now utilize from 20 to 52, or I mean 22 to 52.
yeah, so now you're saying, okay, if this is the case, all right, oh, Houston, you need 400 addresses. All right, so that's the 20 and 21 net. Okay, here's those two used for Houston for wired. Well, Mexico City, I need 150, okay, wired. And wired has got to be within this range of 20 to 52. All right, so from 20 to 52, I've already used from 20 to 52. Here's our ranges for wired. So I've done 20 and 21 here. That's given me 512 addresses. What am I going to do for Mexico City? I need 150. Okay, so I got 150 I need. Okay, I need 400 for Houston here. And how many do I need for Portland?
175.
Okay, 175. So what should I use? I want to stay between the 20 and the 52. So I've used 20 and 21. What should I use for Mexico City? And what should I use for Portland then?
20, use 22 and 23 for Mexico City.
You could do 22 and 23 if you wanted. Now, do I need 23 here?
No.
You wouldn't, right? Because you still keep it under that 256 limit.
Yes, because 150 is less than 256 in a standard class C. So the 22 net right here, if I just did this, okay, 22 net, I'm just going to call that 22 net. And that, of course, is 256 addresses, right? And then I could use the 23 here and get another 256. And that obviously covers my 175 IP address need for my wired. Okay. Now, here's a valid functioning layout here. Here's a design for the wired. And we do the same exact thing for the wireless, okay? But the wireless, they want you to stay between 53 and 60. And of course, when you look at these, you need 150 for wireless here, you need 70 here, and you need, what is that, 225 here, okay? So, yeah, so you're still under this 256, so you could use within that range for wireless. You could just break those out and do 3 class Cs for the wireless as well for those different sales sites or whatever. Okay, here's the advanced question. Now this of course works, but why would you not do this? Why would you not use 20 and 21 here, 22 in Mexico City, and 23 in Portland? Why would you not do that?
If Houston requires, or can I answer it?
Yeah, go ahead.
If Houston requires more in future, then you need to adjust not only Houston but also Mexico City and Portland at the same time. So I'll rather put it on 30 and 40 for Portland or something like that. So if we need to extend it, we don't have to interfere with each other.
Yeah, so if Houston is at 400, and let's say they have growth and they hire a bunch of new sales guys or gals, and they get to 513. They don't have enough IP addresses now. Now I need to give them more ranges. Maybe I need to give them another range here. Maybe I need to give them the 22 net. And then, but I'm already using that for Mexico City. So, okay, shoot. Well, okay, I'll make that 23, and then I'll make this 24. But see, when you are configuring routers and you make a change, you have an outage. And people don't like it when stuff stops working and they have to renumber servers and they have to get new IP addresses and they, so rather than have an outage and reconfigure all three routers on Houston, Mexico City, and Portland, remember they gave you a range here of 20 to 52. And they said, do with this how you want. So now you're like, okay, you know what? And remember, that was a good question. I think it was Raul that asked, well, I think we both thought of it, right? Raul said, well, we're going to have some waste here. Was that you, Raul? We're going to have some waste. We're never going to hit 400. We're never going to hit 150. And we're never going to hit 175. So they've given us this range. It's for our use. Why don't we use the 20s here, looking at this range, 20 to 52, the 30s here, and the 40s here. Why would I say that? I would say, well, I can say, I'm going to start this with 20, okay, 20 through 21. And you know what? That's pretty close to 400. You know what? I'm going to go 20 through 24, or 23, sorry. That'll give me 4 subnets. 20 through 23, that gives me 1,024 addresses with a /22 mask. So that's a 252.0 mask. And here I'm going to start in the 30s. Okay, so I am going to do, so 20, 21, 22, 23 here. That'll give me 1,024. So I am thinking of future growth. Mexico City, well, it might hit 256. So what if I do 30 and 31 here with the /23 mask? That gives me 512 addresses. And then I've got 40, okay, 40 and 41 or something like that here. That gives me 512, sorry, 512. I'm staying consistent here with a /23 mask, a 254.0 mask. So I've got these big ranges. I've got now plenty of IP addresses for wired for future growth. I don't have to touch this. Let's say I had 1,000 sales sites. You don't want to come back and have to revisit this in a couple of years if they're hiring a bunch of people. Okay. So if I do though, if I had to come back, let's say Houston grows too big or something, or maybe Portland really takes off. Okay, I've still got a bunch of other subnets in the 40 range and even into the 52, right? I've got the whole 30 range, which is like 10 class Cs, and the whole 20 range for these. They can expand and say, what if these are regions? What if this is a region like this right here for Portland? This is the Northwest. And so they say, hey, we want to open up another office in Seattle, right? Well, that's easy now because I didn't put these right next to each other back to back. I said, well, if I've got the 40s for the Northwest region, I use 40 and 41. Maybe I'll grow to 42, 43. So I'll make this the 44 net. 44 and 45 net. You see what I mean? I'm not affecting any of these other subnets. They're big subnets. There's plenty of IPs. Nobody gets, I don't have to reconfigure Mexico City, Houston. They got a big range that I'm using. I don't have to worry about it. It's very simple for me. I know the 40s is the Pacific Northwest. I know that Latin America is the 30s. And I know the 20 net ranges is the Southwest, Houston. If they want to do another one in Austin, boom, I'll give it 24 to 25 or something like that. You see? You see how I've got these ranges now divvied up, broken up between regions. It's very simple for me as a network engineer to figure out, to understand, okay, they say you got a device problem. What is it? Well, it's a 172.16.40 net, 40.3. You got a problem with that. I know immediately it's in Portland because my 40s are in the Pacific Northwest, but 40 through 41 is in Portland, right? So this helps me remember this. Is this helping you get some ideas on how you could architect this with some flexibility, some room for growth in the future?
Yes.
Yes.
So
I think
yeah,
you made
yes.
it. I'm sorry, Mark. I need to confer with you just real quick here, cover some of these points. I absolutely agree with you. You're leaving spaces between to allow expansion in specific ranges, which you can use regionally to expand. I think that is really good. Has there been any consideration with your own network experience as to whether or not you build in a figure or a percentage of natural growth? Like you wouldn't just double it for no reason, or you wouldn't account for so many BYOD devices. Is there a general rule that you might consider when putting these numbers into play?
Well, that's a good question. If you've got all of these ranges and your central IT is giving you this whole range to work with for your sales regions in North America, you want it to be, like you say, flexible, room for growth. You're like you say, BYOD, start bringing their cell phones, they start bringing a whole bunch of other devices, and all of a sudden you're like, well, we need way more than 400 devices, way more 400 IP addresses in Houston, right? And so you've got plenty of room to growth. I think, Peter, you had a good example where you had the student network at SMU,
Yep.
and there's only 1,700 students, but how many IP addresses being used?
Well, when I talked about it last time, that was actually the outside addresses that we had before. But right now, I've got it set up for, I want to say 250,000 addresses. So
he
yeah.
jumped way up. He jumped
Yeah.
way up. Just give them a huge range. You configure it once, never have to touch it again. But
it wasn't the decision wasn't really based on the number of IP addresses and matching that. It was more of a management. Okay, I'm going to have this range number wise for the like the 100 range. 10.100s are going to be for students, and so they actually have 10.100, 10.101, 10.102, 10.103, 10.104, 10.105, 10.106, 10.107, and 10.108 available. Obviously, we don't use all those, but it's just easier for me to manage, to remember that anything under 110 is a student.
Yeah.
Mark, I had some other kind of pertinent questions regarding some of the fundamentals of what you've covered so far. To go back real quick to the fundamentals, when you're talking about these subnet masks, for example, we touched on the IDR, and using that number, I think I got a big explanation kind of go off as like a light bulb. If you're to do an IP config on your own machine, you realize that your subnet mask is all 255s. And as an individual host, you don't have anywhere to assign anything because that only gives you your basic IP address. What is it like? So it'd be a /32 for your own CIDR number for a specific machine. Now go back up to the big machines outside our network. There was some question in my mind because when you look at a subnet address, as you stated, part of it insinuates, or not insinuates, it determines what part of it is going to be the network and then what the hosts are, which means in my mind, would that be a hard copy of what you can administrate to assign versus what you're given as the bits taken up by the network above you? And to be more specific, my biggest confusion so far is that when you look at things like the CIDR and you're saying, well, how many addresses are we getting? I have to keep remembering that the octets are all in decimal. And whenever we do a change, those are always in binary to the system. And that's what, as you said, that's why you keep jumping from 256, 512, 1024. But decimally, it's kind of confusing. So my three views were how you separate host versus network, the subnet CIDR as to how it increases as you get smaller, and how you, I think you just answered this, whether or not you would allow for a lot wider range for BYOD and so on. But I think I needed more time to work on that separation between host and network and who administers those numbers above you. Like the first two octets, we're oftentimes just given those. Then of course, then from there, you can design your network below those. And so I'm assuming, and my final point is that, are you saying that the subnet mask, its sole purpose in most of these cases is to tell you what you can't use, and then what you're allowed below that to actually umbrella into for your business or other IT needs?
Okay, so a lot going on there, but let me try and knock out some of these. So when you do that IP config and you see what IP address you have and what mask you have, those two determine your subnet, well, and your gateway, okay? That determines your subnet, and the mask determines how many IP addresses are on that subnet. And so when you have a /24, like a standard class C, that's typically how like a home router is, wireless access point, it multiples as a router, wireless access point, switch, firewall, right? Well, network address translation. So all those things, that when you look at it from a corporate environment, like where Peter is working at St. Martin's, he is determining himself, or he and Neil, how to break out those numbers. Now, when he used a 10 net or he used a 172.16, these are private ranges that Peter is determining himself how to break these out for Panowitz or Cibula or some type of dorm room, okay? He's determining that. And, but when he got like a partial class B range, he got that from the IANA. This is a organization that actually registers these public IP addresses, these ranges, to specific companies and universities and so forth. So they gave him that, and from that, then they give him that big old chunk, whatever that is, and then he determines how he's going to divvy that, subdivide that with St. Martin's. So they're just giving him a big, huge chunk of IP addresses, and then based on the different types of subnet masks, he's breaking that out into different subnets. So it's all up to you or all of us if we were all network engineers. And in this exact homework assignment, okay, you've got North American sales sites, Mexico City, Portland, Houston. You've got this big old range that your central IT said, here, use this. And you get to subdivide it yourself. There's no wrong or right. There's a better right than right. You know what I'm saying? Like I want to just explain, hey, don't use 20 and 21 in Houston, and then 22 in Mexico City and 23 in Portland. Because when Houston outgrows 400 IP addresses, you've got to reconfigure every one of these routers. And that's going to be a mess. You're going to have outages. People are not going to be happy, that kind of thing. So you've got plenty of IP addresses to use from, spread them out, give yourself double what you need. If you needed 400, that's close to 512, double that, 1024. People bring their own devices, bring their cell phones, bring their own tablets, whatever they do, bring their game box. I don't know, maybe they add a whole bunch of different things to the sales office. A whole bunch of IP addresses start to get used there. Maybe they create a little lab inside there or whatever. You're still good to go because you have this huge range that you've created for them. And I mean, it doesn't have to be so massive. It doesn't have to be like 65,000 addresses for 400 people or something, but you have the ability to subdivide it the way you want to for your company. Peter, you want to add anything to that?
Absolutely. Yeah. In fact, you can actually think about it the opposite way. Pretend, for example, the same situation where we've got different regions of the country, except you're in charge of, say, networking for a restaurant, a fast food joint, say your McDonald's, and you have, say, 50,000 locations that you have to IP address for. And so you may not have very many actual computers there because you're serving food, not actually making, software or anything. So you'll have probably, say, 10 computers per location, and but you'll have 50,000 locations. So your subnetting is going to be a lot different than what we've got here, and it's going to be a lot more locked down because you have to have that many locations. Does that make sense?
Oh, absolutely. In fact, you guys covered everything. I obviously was trying to point out that you were handed the 172.16 for an example in this exercise, and from there we could learn to use the subnet calculations to determine what range we're able to apply. Yes. And then there's also obviously situations where you might be in a hierarchy, as you mentioned, that might require umpteen thousand, to where you might even have to look at different class recommendations for that. So I appreciate the overview. That works.
So for the Portland and Mexico City ones, are you just using a 255 subnet mask?
Yeah, you could do that, and that'd give you 256. But again, Portland at 175, even Mexico City, they're 150 right now. But if you looked at, well, where's Portland and Mexico City going to be in 3 or 5 years? You think they're going to hit 256 addresses? And if you do, then instead of just doing a 255.0, the /24 mask, maybe do a 254.0 mask, a /23, do 2 ranges for Mexico City and Portland, and that would give you 512 addresses.
Yeah, there's no reason why you shouldn't be able to do that, especially since you've got 32, 33, 34, 35, 36, 37, 38, 39 available before you start running into Portland's address range. So does that make sense?
For all the stuff the network engineer has to do, he doesn't want to redo work that he's already done. And for you to have to reconfigure and add another subnet to these because they ran out of IP addresses, that's what you don't want to do. So that's why I just said, might as well throw, we've got room. And yes, it's true that if you just gave yourself 512 usable addresses or 510 usable for Mexico City, and you only got 150 wired clients that you really need IP addresses for, that seems very wasteful. But this range has been assigned to the North America region, and if you don't use them, they're just going to sit there unused anyways.
Right.
So you might as well configure them and allow them to be used if needed by configuring that on the router. And once you configure that on the router, then you've got those addresses ready for you to use at any time. No problem. You have some type of training or sales event and all these people come and they get on your guest network or something and they all get IP addresses or something. You're good. You're still golden. You've got, you know, a double, triple what you need. So you've got flexibility. So that's what I was trying to convey there. Okay, so we're running out of time. So I wanted to see, I wanted to kind of get, if you just look at this, you're like, I have no idea what to do. But now you're starting to see what the answers are to these questions at the bottom, these 13 questions. We talked about how will you determine the number of IP addresses required for each location, but we only did it for wired. So how do you answer that for wireless? Again, same thing applies. Now you have some insight into that. You know what the wireless range is. You can throw in some ranges there. And then the rest of these questions, see if you can answer on your own before Thursday. And then we'll review this on Thursday. How many laptops have both wired and wireless? I think we figured that out. What's a simple subnet class? Now this is maybe a trick question. What's the simplest subnet class to use when planning an IP address scheme for each of the branch offices? Most people know of a class C, 256 addresses, /24 side notation, which is 255.255.255.0. That's what they know. But as you've seen, this can be subdivided up in various different ways. Supernetting going to the left, stubnetting going to the right, you know, with that line of class C, that /24, 24 bits, going to 25, 26 bits, or going less, 23, 22, 21 bits. So this can be changed up, and that's what variable length subnet masking is. You choose, assuming you have enough ranges to work with, you can choose how you want to do that. So this is an interesting question. What is the simple subnet class? And
So is that you wanted to put us on cider notation, or what will be the answer?
yeah, notation is the same as just the decimal, you know.
Yeah.
But in this case, some people think a class C is the easiest. So for Houston, you need 2 class Cs, right? They'd say, okay, well that's 400 addresses. If I get 2 class Cs, then I'll just use the 20 and the 21, but they'll be 2 separate addresses. Okay, 2 separate networks that I'll put on to, but that is actually not the simplest to configure, because then you'd have to have a primary and a secondary subnet or address there, and you'd have some things where you'd have to route between the two. So really it's using variable length subnet masking, VSLM, variable length subnet masking. So using that to determine with the subnet mask how many IP addresses will you use, and it combines those into one with the change in subnet mask. One virtual subnet. Okay, so go through these questions through 13. We'll see if we can't answer these Thursday. Work with each other. It's not like you only have to, you know, reach out to each other, work through this, and then let's review this and let's finish it up, and then you can submit it to Moodle. Okay. Okay. Any final questions? Ian, did you come back? I guess Ian's not there. All right. Any other questions?
Nope, all good, sir. Thank you.
All right.
I think we're good, Mark.
All right. We will see you Thursday then.
Thanks, Mark.
Okay. Bye, everyone.
Well, he left.